Well, hey there. Here we go. We're going to do day 3 of our notes. We are doing standard form of linear equations. Last time we talked about functions and we evaluated functions and the difference between an equation and a function. Today we'll specifically talk about linear equations in standard form, but just knowing that they can be represented as functions down the line. So what is a linear function? And we're going to talk more about what this ax plus b, actually I'll start there. Linear equation in standard form is ax plus by equals c. So that'll be common if the directions say write in standard form. That is the form I'm looking for. A is a constant term, and ax and by are the variable terms. A should always be positive, so I will write that there. This is a lot bigger because I have this all shrunk up. So this is, my pen doesn't want to work. A is always positive. All right, so we'll write our equations in standard form today when we get to that. A linear function, well, how can we identify something as a linear function? It's something that is a non-vertical line that has a constant rate of change and can be represented as a linear equation. So again, today we'll talk about specifically the standard form. Linear equations have variables, x and y. Sometimes they won't have both, but one or the other, or both. With degrees of 1, and they cannot be multiplied or divided by each other. So here I have the equation that we had from last time. Y is equal to 1/3 x plus 5, and then here it is in function form. We will see a lot of things like this today, but we won't be graphing them as you typically have graphed that equation before. So for each equation, graph, or table, we're going to determine if it represents a linear function or not. So again, linear is non-vertical, and it has a constant rate of change. And it's a line, obviously. Linear is line. So this guy right here is definitely linear, because it's a line. This guy here is non-linear. And then we got these tables here. How do we figure out if those are linear? Well, by definition, it says a constant rate of change. So a constant rate of change between the x and the y. So if we go here, this is plus 4. This is plus 4. This is plus 4. So that's a constant rate of change in x. This guy here is minus 4. Oh, that's minus 5. And that's minus 6. So no, this is non-linear. And that's specifically because this is not the same. It would need to be minus 4, minus 4, minus 4 for it to be linear. So we probably could see that in my next example, we might get something linear. So here we have plus 1. This really doesn't want to work for me tonight. Plus 1, plus 1, plus 1. So that's a constant rate with x. Here I am subtracting 15, and subtracting 15. So there is a constant rate of change between the x and the y. So this is linear by looking at a table. All right, and again, domain there, if we recall, is all of our x values, and y is all of our range values. So looking at an equation now, is this linear? And most of you are like, yep, I know that's something like mx plus b. We'll learn that next time. But this y has a degree of 1. It's not there, but we assume that's 1. This has a degree of 1. And they're not being multiplied or divided by each other. So that's a good thing. So then it is linear. Yes, linear. by checking out no multiplication or division, and degrees are of 1. So how do I write this in standard form? So if I need to write, I'm going to rewrite it here. You have it on your ax plus by equals c. You have it on your paper right up top. I need to get it in that form. Right now I have x and y on two different sides of each other. So I'm going to move that 1/2 x to the left. And so that'll be minus 1/2 x plus y is equal to 3. But a and b and c need to be constant numbers in my definition up here. Our variable terms, I actually don't have there, that a and b need to be whole numbers. They can't be fractions. So I need to get rid of this fraction here, and we did that when we solved linear equations. How do we do that? By multiplying the whole thing by a -2. So I need this to be positive, and I need a to be positive, and all of my coefficients, the numbers, to be integers of some sort. So a non-variable. All right, so if I multiply this inside, I get x minus 2y is equal to -6. So that is the standard form equation of that function, or linear equation. All right. F there. This guy right here, x and y are being multiplied. So it's definitely nonlinear. Okay. Even though they have degrees of 1, they're multiplied. G here, y is to a degree of 1, but x is a degree of 2. So that is nonlinear. And this one here, we got an exponent of 1 on the x, an exponent of 1 on the y. They're not being multiplied, but it definitely looks icky, not in standard form. So again, I definitely can say it's linear by checking out that it's not multiplied, and x and y aren't multiplied, and the x and y have degrees of 1. But I need standard form. So I'm going to rewrite that ax plus by equals c. A, b, and c need to be integers. A specifically has to be positive. So x and y are not on the same side. But first, let me just get rid of this fraction thing. Like, let me get rid of the 4 and the 3 by doing what? Multiplying by the least common multiple of 4 and 3, which is 12. So that is why we did when we solved linear equations, when we just solved regular those equations, we canceled out these fractions by multiplying by that 12. So if you recall, it's 12 divided by 4 is 3. 3 times 3 is 9x. Let me redo this. So distribute that in. So that's 9x is equal to, distribute that 12 into the 2 over 3. So that's 12 divided by 3 is 4. 4 times 2 is 8. Oh my gosh, what's going on here? 8y, and then minus 60. My pen does not want to work for me. All right. So again, I need a and b to be on the same side, or x and y to be on the same side. So I need to subtract this 8y. 9x minus 8y is equal to negative 60. So that, in fact, is our standard form linear equation, standard form of that. All right. A little jumbled there. Forgive me there. And we'll keep working on this standard form stuff as to when we actually see these equations and we might have to rewrite them. So if I come back up here and write A and B are variable terms, I should probably have there that, like A and, A, B, and C, A and B, because it kind of says constant for C. A and B are integers. So whole numbers are, not fractions. All right, maybe I should say not fractions. All right, if we go back to something that we've done in the previous 2 times, our lessons is talking about x and y intercepts when we have this graph here. So we've been able to do that. And what is an x-intercept? That's where it crosses the x-axis, right? So if we talk about the x-intercept here and interpret the meaning of it, so x-intercept, I put a little black dot where that graph crosses the x-axis, which is the horizontal axis, and it's at 6. So the x-intercept is 6, 0, right? The y is 0 there. So the height is 0. It's a descendant of the descent, not descendant, descent of the eagle. So the eagle has an initial height of some sort, which is another intercept, and it goes all the way down and hits the ground at 6 seconds. So that's what this intercept means, is at 6 seconds, the eagle lands. Ooh, I'm getting impatient with my iPad pen. Y-intercept. That's where it crosses the y-axis. I probably should have done that one first. That makes more sense. But listening here, it looks like it's at 20. So my y-intercept, though, is not just 20. It's 0, 20, because the time is 0 seconds. So the initial height of the eagle is 20 feet. We also interpreted it as at 0 seconds. The eagle was 20 feet in the air. That's fine. Even with the x-intercept, you could have said at 0 seconds, the eagle was at 0 feet, right? So we found those intercepts, but what if I was given an equation like this? This equation, 20x plus 6y equals 120, represents the height, y, feet, of the eagle at x seconds. Algebraically find the x and y intercepts. So that's pretty much the basis of this lesson today, is finding x and y intercepts without actually looking at a graph. And so if we look at these things up here that I've already written out, x-intercept and the y-intercept, x-intercept has a y that is 0. So I can actually plug in 0 for my y and solve for x. So really, 6 times 0 goes away, and I'm left with 20x is equal to 120. Divide both sides by 20. And I have x is equal to 60. But I don't leave it like that. That's just a solution, right? The actual intercept is, oh, not 60. You know what? I did that earlier. 6, 0. And that's, in fact, what we found on the graph, too. So, furthermore, we could do 20 times 0 because the x is 0 for the y-intercept. Plus 6y is equal to 120. So, again, this is just like the 20 times 0 goes away. I'm left with 6y is equal to 120. Divide both sides by 6. Y is equal to 20. But we don't write it like that. We write it like 0, 20 as an ordered pair because intercepts are ordered pairs. So looking at a standard form equation, finding the intercepts are really nice as long as A and B divide C nicely. So we got some of these here. Write each equation in standard form. AX plus BY. Oh, that should be a capital C. AX plus BY equals C. Then graph using the X and Y intercepts. Okay, so let me just put that there. You might have some space, or I'm just going to write it again. Actually, I'm not going to do that now because it just messed up my spacing. We know that A needs to be positive, and they can't, no fractions. We'll just say no fractions. And it needs to have X and Y on one side, constant term on the other side. Variable terms on the left, constants on the right. So A here is really nice and easy. It's already in a nice standard form. AX plus BY equals C. So to find these intercepts, I'm going to plug in 0 for X to find the Y-intercept and plug in 0 for Y to find the X-intercept. If I was in front of you, I would do something along the lines of something called the cover-up method. Because when I plug in 0 for Y, this I can cover up, and I'm left with 2x is equal to negative 10. So then x is equal to negative 5 by dividing, all right? And so I have negative 5, 0 is my x-intercept. I now need to do the same thing for my y. Plug in 0 for my x to find my y-intercept. So 2, 0 plus 5y is equal to negative 10. So again, I could just cover up the x, and I'm left with positive 5y is equal to negative 10 when I divide both sides by 5. Y is equal to negative 2. I don't leave it like that. I express it as an ordered pair. So now I have two ordered pairs that are intercepts that I'll go ahead and graph. So I'm going to graph this and graph this. And then you should have some popsicle sticks that Mr. Smith might have in there that you can use after we graph. I think it's very nice to have a popsicle stick because then we can make nice straight lines. Once I graph those two ordered pairs, I can connect them. And I have a nice line because this is a linear equation. So again, we can always plug in 0, but we can also use the idea, what if I cover up the x to find the y, and then cover up the y to find the x? All right, B. B is not in standard form. To get it in standard form, I can move this 7x to the left. That would make that x positive, or a positive. So 7x plus 4y is equal to 28. So to find the x-intercept, I'm going to plug in 0 for my y. Again, that's a little redundant. This goes away, so I'm left with 7x is equal to 28. Divide. So x is equal to 4. And that is 4, 0 is that x-intercept. To find my y-intercept, I plug in 0 for my x, or cover it up and just, because we know that this goes away, so I'm left with 4y is equal to 28. Divide. Y is equal to 7, but we don't leave it like that. We express it as an ordered pair. So I have 0, 7 as my y-intercept, and 4, 0 as my x-intercept. Now that I have those 2 points, I can take a popsicle stick, or if you got a ruler, and draw a nice line. In tonight's homework, you will just plot one point, then plot the other point, and it should create the line for you. Okay? Not so bad, but definitely using our algebra skills, right? Understanding what it means to be an x-intercept or a y-intercept, and then graphing. All right, this guy here, I can kind of move some things around, and most of us can kind of move these things in our heads, but how I would go about doing this is probably adding this x to the left and adding the 3 to the right. So adding x over here, it goes away over there, and I'm left with x minus y, that goes away there, is equal to 3. Ooh, this is a nice and easy one because x and y have coefficients. A and b are essentially 1. Not essentially, they are. So if I find the x-intercept, I would plug in, let me change back my color. I'd have x minus 0 is equal to 3. That just goes away, so x is equal to 3. 3, 0. To find the y-intercept, I plug in 0 for x. There I have a negative. That's kind of a common thing. Students will forget that negative is still in front of the y. It goes away when we multiply it by 0, but it's still in front of that y there, so I'll need to divide out that -1. Y is equal to -3. 0, -3. So we will plot those ordered pairs on our intercepts and then use a straight edge, hopefully, to make a nice straight line through those points. Excellent. Very cool. And some of you might be saying, Ms. Coates, I know how to graph these so much different because I don't have to do this, and I understand that. But hopefully we are learning that we can find different elements of a function given we know different things about them. Specifically these intercepts. X and Y are 0 at these intercepts. All right, this guy here, it is definitely not in standard form. I'm going to move the y over there with the x first. We might lose some space here. All right, and then in order to get this in standard form, I need to have a positive, and I can't have those fractions. So then I'm going to need to multiply by definitely a negative, and to get rid of this 3, I would need to multiply by a 3 as well. So negative 3, multiply this whole thing by negative 3. When I make that distribution, I'm going to get 5x plus 3y is equal to negative 30. That is now my standard form. So I've answered that part. That one was definitely a little harder than the other 3 that we've had before, right? Because of that fraction, and a was not nicely positive when I moved it. All right, so go ahead and find those x and y intercepts. You can avoid me for now and do it. Find those intercepts and graph, and then check back with me. All right, if you're still working and need to pause me, you can pause me and come back. And I keep moving. That looks a little funky at the end there, but that is an arrow at the end, right? Make sure we have arrows at the end of our lines because they are continuous. We want to make sure that we have those arrows. All right, so this next one here, definitely not in standard form. I got fractions, and I also have x and y not on the same side. So I'm going to move that y over to the left. Y can be, meaning b can be negative, so the coefficient of y. I need to get rid of that 5 and the 3 because they're both fractions. So you're all coming back to me now. From equations, how do I get rid of that? LCM of 5 and 3 is 15. Multiply 15 by 1/5, that's 3x. Negative 1/3 times 15 is negative 5y. And then we have 15. So there we go, nice standard form. And then hopefully we are kind of in a groove now on how to find the x and y intercepts. X-intercept, I need to do 3x is equal to 15, and that's because I plug 0 in for y. That cancels out the negative 5 times y, right? And that is x is equal to 5. 5, 0. So again, if I cover up the x, and I have negative 5y is equal to 15. So plugging in 0 for x, that cancels out. So I have negative 5y is equal to 15. So y is equal to negative 3. 0, negative 3. I'm such a stickler for my lines. They definitely need to go through your points. All right, we've had lots of practice there on getting in standard form, and now I know I gotta edit my little definition up there. Standard form, A and B and C have to be not fractions, and A needs to be positive. Remember our linear equations, exponents are gonna be 1. Up here, or back in the on the front of your page, when it says standard form, linear functions are graphs that are non-vertical lines, and we might see a vertical line here, but we just won't be able to write it as a function down the line. All right, so this guy, x is equal to 4. X is equal to 4. Let's just find where x is 4. X is 4 right here, is it not? It sure is. Oh, but I think x is 4 right here. So if I was in class, I would say, hey guys, pick another point where x is 4. So 4 comma something, 4 comma anything. So I can have 4 comma 8 up here. Anything that x is equal to 4 is going to be on that line. And that is a vertical line that goes through the x-axis at 4 is the equation of the line for x is equal to 4. So no, this is not a function, right? Because this is a vertical line, which would make not cross the vertical line test. So that's a very specific one that even though it's a line, we don't necessarily consider it a linear function. Special vertical line, x is equal to whatever, because it'll go through the x-axis. And if we see that line, all the points on that line, x is equal to 4. All right, so what about our y? Y is equal to negative 3. I'd tell you, go pick a point where y is equal to negative 3. I know that's a point where y is equal to negative 3. I know that that's a point where y is equal to negative 3. Y is equal to negative 3 right here, right? That's negative 5, negative 3. So that is a horizontal line through the y-axis at negative 3. And that doesn't really have a constant rate of change. We'll learn more about what that slope is down the line, but it is considered a constant function. Constant linear function. It's just a constant number. All right, I think that's it. It is a lot of stuff, but practice, practice, practice. It might be something different you haven't seen before. Let's keep doing this work so we can become very proficient. Miss you guys today. I'll see you in the halls around school, though. All right?